Hello everyone. Previously we seen the details of magnitude comparator, basic details of magnitude comparator. What is the actual basic definition of comparator? What is the magnitude? What is the actual types? That is the 1 bit, 2 bit, 4 bit. We seen in details also. 1 bit means how many inputs, what is the outputs, and same as the 2 bit. We seen the block diagram. We seen the what is how the cascading will be used. And all that concept in previously we seen in magnitude comparator. Same this part will continue in this today's session, that is the magnitude comparator. And today we seen the in details how it works, that is the 1 bit, what is the actual truth table, what is the how is the output generated, how to draw the k-map, and what is the actual logical equation and how it proves. That is the steps. And that steps today we are following. The first one, magnitude comparator, that is the digital comparator. It is combinational logic circuit. It is combinational logic circuit, and it compare digital comparator as well as magnitude comparator is used to compare the value of two binary digits. Already we seen in previously. There are two types of digital comparators. That is the identity comparator. It will be related to equal sign, and next one magnitude comparator, that will be related to less than and greater than sign. Okay, we see the here and detail. Here is the detail given. Identity comparator means this comparator has only one out terminal, has only one output terminal. Or when a equal to b means the indicates equal sign. In that case it has only one output terminal, either a equal to b equal to 1 means it is high, otherwise low. Means equal sign when it becomes either 0 or 1, in that case we are calling as an identity comparator. Now we go ahead, that is the magnitude comparator. These comparator having three outputs terminals, that is the a greater than b, a equal to b, a less than b, but it depending on the result of comparison. Means whatever the a inputs, b inputs, it will be compares with each other, and that results, whatever the results, in that basis we generate the output. From this output will be high. Means whatever the given three conditions, from one of them the output will be gets high. The block diagram it will be given details here. Here given two inputs, but in that two inputs there are number of bits n up to the n bits. For example, a1, a2, a3, a4 up to the an. Same for the b1, b2, b3 up to the bn. This n number of bits are given in a, and b it has also having n number of bits. Hence in this block diagram we are given the name, that is the n bit digital comparator. It having three outputs, that is the a less than b, a equal to b, and a greater than b. Means each magnitude comparator having mainly three outputs, that is the comparative outputs, and the inputs will be changes as per the which types you are taken, 1 bit, 2 bit, 4 bit, 8 bit. In that condition it will be generate the how many bits we are using, that will be generated from the given inputs, but output will be fixed. Now we go to the stepwise. That is the first one, 1 bit magnitude comparator. Here the magnitude comparator having two inputs, that is the a and b, here given truth table, and output is 3, that is the a less than b, a equal to b, and a greater than b. In that, it compares with each other two numbers of single bits. Okay, now we start the compare. For example, a having 0, b having 0 means a also same value, b also same value, means it will be generates 1, means a equal to b, because two a and b is the having same value, hence the output will be generated 1, means output will be 1, means output will be high, in which case that is the a equal to b, means hence it is the 1, remaining is the 0. Okay, now go to the next stage, that is the 1 bit comparator. A is the 0, b is the 1. You compare with each other a and b, which value is the highest, that is the b is the having highest value, and a is the having less value, hence here is the a less than b, hence it is the 1, remaining is the low value, that is the 0, and it will be high. Next input, a is the having 1 and b is the having 0, means a it is the highest value, b is the lowest value, means a is the greater than b, means here is the 1, remaining is the 0. Okay. Next inputs, a is the 1, b is the 1, that is the a also 1, a is the high, b is the also high, means 1 1, means a is the less than 0, that is the 0, because a and b having same value, hence it is the equal value, a equal to b, hence it is the high, remaining all the zeros. I think all of you clear that, very easy concept. Whatever the same value, then it will becomes here largest value, then whatever the largest value, it will be mentioned 1, remaining 0. Now for the, here is the outputs, 3 outputs, and here is the 2 inputs. Now we have to draw the cameo. 2 inputs means we have to require 4 cells. Okay, here draw for the first one, that is the 2 inputs a and b, 0 1, that is the a bar a, b bar b. Okay, for a less than b, a less than b, 0 1 2 3, there is the 4 cell, means one is the one cell is the high, remaining all these the 0. Here we taken 0 1 2 3, 1 is the high. Now you solve that, here is the b, here is the a bar, means a bar b, that is the answer of first one, that is the y1. Is it clear? A bar b, here is the bar a bar b. Next one, for the y2 purpose, go through table. Y2 0 means first cell is the 1 and last cell is the 1. It is the first cell is the 1 and last. Now we solve that. The first one, a bar b bar, here is the a bar b bar plus a b. Okay, that is the y2 equation for a equal to b. Third one, only single one is the present, that is the third number cell, is 0 1 2 3. The equation will becomes a b bar. For y2 purpose, sorry, y3 purpose, that is the, here is the y3, a greater than b, we get the equation, that is the a b bar. Now this is the equations, first one, second one, and third one. Using of this equation, you have to draw the logical diagram. Here we taken the first equation, that is the a bar b, that is the a bar b, a bar, here we connected not gate, that is the a bar, and b will be directly connected, and that is the AND gate, that is the first one. The second one, a bar b bar. Here is the a bar. From b also we taken the not again. We gets a bar b bar. In the same, another one in the second, that is the last cell one is the generator, that is the a and b. Here we connected a and b. That is a bar b bar a b. It is connected with OR gate. We get the equation, that is the a bar b bar plus ab. That is the y2 equation, that is the a equal to. In third equation, that is the a b bar, that is the a already comes here, and b, that is a b bar means a greater than b. That is comes y1, y2 and y3. This equation will be, that is all about the one bit comparator. Same, this equation we are using by using XNOR gate. Here we connected, that is the a XOR b bar means a XNOR b. Okay, remaining equations are only one variable. There is the two variables. Hence, that is the XNOR gate. Hence, that is XNOR a XNOR b means a, and from b we given here, and that is the XNOR gate. We generate the output, that is the y2. Now 2-bit comparator. It will be used for two binary numbers. Each of 2 bit is called as 2-bit. Means here is the 2 bits. In figure shows, that is a0 a1 b0 b1, and output will be same. That is a less than, equal to, and greater than. Here given greater than, a greater than b, that is for a1 a0 b1 b0. If a1 equal to 1 and b1 equal to 0, means a is the highest value, then a is the greater value. a1 and b1 are same. In that case, it is the 1 or either 0. That is the equal, and less than, a less than b means a equal to, and a1 equal to b1 equal to 1, and a0 0 b0 1 means it is the highest value, means b is the least, hence a less than b. Okay, same here, another one example is given. Two terms are 0 and here is only 1, again a less than b. Here taken a1 a0 b1 b0 means it having 4 variables, means 16 numbers, that is the from 0 0 0 to 1 1 1. Output will be same. There is the 3 outputs, a less than, a equal, a greater. Now you take the any one example from here. First one, all the values are same, hence one will be generated because it is the it equals with, a is equals with b, hence here is the 1. Now you take the any one value here. Here also 1 1 1 1 means there are, here also a side there are 1, here also b side there are 1, and so on. Now you take the here example 0 1 1 1. Here 0 1 means here is the less value as compared to b1, means a1 and b1 compares, here is the highest value, and b0 it is the 1, here is the a0 also 1, but it is the highest value, hence it comes here, that is the a less than b, because a having the b is greater than, means here is the b greater. You take another one example 0 1 0 1, means it is the 1. You take here 0 1 0 0, means a is the greater, means here is the mention of. And using of that truth table, this is the input side and this is the output side, means here is the 4 inputs, means we require 16 cell kernel. Here we draw them. A0 A1 B0 B1. Whatever is the present values we putting, we prepare that code. Here is the pair, here also one pair, and we test the equation. For code purpose we check the one equation, remaining you see here that A1, because A0 will be gets cancelled, and here B1 means A1 B1. Is it clear? A1 and from here B1. Okay. Same, you take here B1 B0, B1 B0, and here A0 bar, B1 B0, A1, sorry, B1 B0 and A0 bar, B1 B0 and A0 bar. The bar will be here. Same chord purpose also, last we seen, here is the one present, here is the one. Remaining terms will be gets cancelled, means B1, and here A1 bar means B1, A1 bar B1, A1 bar B1. Okay, same this pair, that 0 1 will be gets cancelled, 1 1 means B0, and here B0 A0, A0 bar A1 bar B0, A0 bar A1 bar B0. In A equal to B, it is no any chance for the quad octet pair. It is single ones. Hence we written the equation. For example, first one A0 bar A1 bar B0 bar B1 bar. Okay. Second one B1 bar B0 and A1 bar A0. Third one B1 B0 A1 A0. Last one B1 B0 bar A1 A0 bar. Same for the A greater than B, we get the equation that quad pair and another one pair. And after we got the equation, we simplified that using a Boolean algebra. Already we seen in previous video also. You have to use here different types of laws. Here we taken common terms in outside A0 B0 bar, here A0 B0. The remaining terms will be comes in bracket, and this is the law of X naught. Here we connected X naught. Okay, because here is the A1 bar B1 bar, here is the A1 B1. Hence we connected here X naught now. Using of that this equation, you have to draw the diagram. Okay, here we directly draw it from the using of these equations, but using of X naught and this also it is a very useful diagram. Sorry, it is the simplified for only y2 purpose. The remaining equations we taken here a1 a0 b0, that is the 4 inputs we connected with each NOT gate, and we draw the logical diagram. Thank you. We will stop here. I think all of you clear the 1 bit and 2 bit comparator. Thank you.